Have you ever wondered why airplanes have tails? It's a question that might not cross your mind often, but the answer is fascinating and crucial to the science of flight. It's not just for looks. The tail of an airplane, known as the empennage, plays a critical role in the aircraft's stability and control. The empennage is a vital part of what keeps the plane flying straight and level. It consists of several components, including the horizontal and vertical stabilizers, which work together to maintain the aircraft's equilibrium. Think of it like the feathers on an arrow. Just as the feathers help an arrow fly straight and true, the empennage ensures that the airplane remains stable and on course. Just like the feathers help an arrow fly true, the empennage helps an airplane stay stable in the air. It counteracts any unwanted movements and keeps the aircraft aligned with its intended flight path. Without an empennage, an airplane would be like a leaf floating in the wind, tumbling and turning unpredictably. The empennage prevents this by providing the necessary aerodynamic forces to keep the plane steady. The empennage provides stability and control, allowing the pilot to maneuver the aircraft safely and efficiently. It enables precise control over the pitch and yaw of the airplane, which are essential for smooth and controlled flight. In this essay, we'll explore the different parts of the empennage and how they work together to keep planes flying smoothly. From the horizontal stabilizer to the rudder, each component has a specific function that contributes to the overall stability and control of the aircraft. So let's dive in and discover the fascinating world of the empennage and its crucial role in aviation. The empennage isn't just one big piece, it's made up of several important parts. The most noticeable part is usually the vertical stabilizer, the big fin that sticks up from the back of the plane, but there's also the horizontal stabilizer, which looks like a smaller wing mounted sideways near the tail. These stabilizers work together to provide stability in different directions. The vertical stabilizer keeps the plane from swaying side to side, while the horizontal stabilizer prevents it from pitching up and down too much. Attached to these stabilizers are movable surfaces called control surfaces that allow the pilot to maneuver the plane. The horizontal stabilizer might seem like an afterthought, but it plays a crucial role in controlling the plane's pitch. This small yet vital component is located at the tail of the aircraft and is essential for maintaining the plane's stability during flight. Without it, the aircraft would struggle to stay level, making for a very bumpy and potentially dangerous ride. Pitch refers to the up and down movement of the plane's nose. This movement is crucial for various phases of flight, including takeoff, cruising, and landing. Proper pitch control ensures that the aircraft can ascend, descend, and maintain a steady altitude as needed. If the nose points up, the plane climbs. This is particularly important during takeoff and when the aircraft needs to gain altitude to avoid obstacles or turbulence. If it points down, the plane descends. This is essential for landing and for controlled descents during the flight. Proper descent is crucial for a smooth and safe landing. The horizontal stabilizer helps maintain a steady pitch, preventing the plane from pitching up or down too sharply. This stability is vital for passenger comfort and for the overall safety of the flight. It ensures that the aircraft can handle various aerodynamic forces without losing control. Imagine holding a paper airplane by the nose and trying to fly it. Without a horizontal stabilizer, the paper airplane would be difficult to control, making it nearly impossible to achieve a smooth flight. It would likely tumble and crash because it lacks the stability provided by a horizontal stabilizer. This simple analogy helps illustrate the importance of the horizontal stabilizer in real aircraft, where stability and control are paramount. The horizontal stabilizer on a real airplane acts like a mini-wing at the back, generating a downward force that balances the plane and keeps it level. This downward force counteracts the nose-up tendency of the aircraft, ensuring that the plane remains stable and level during flight. Without this crucial component, the aircraft would be much harder to control, making safe and efficient flight nearly impossible. Attached to the back of the horizontal stabilizer is a movable control surface called the elevator. The elevator is responsible for controlling the plane's pitch. When the pilot pulls back on the control stick, the elevator moves up. This deflects airflow, creating a downward force on the tail and causing the nose to pitch up. Conversely, when the pilot pushes the control stick forward, the elevator moves down. This deflects airflow upward, creating an upward force on the tail and causing the nose to pitch down. By carefully adjusting the elevator, the pilot can control the plane's climb and descent rate. Section 5. The vertical stabilizer, keeping the plane straight. While the horizontal stabilizer deals with pitch, the vertical stabilizer is all about yaw. Yaw refers to the side-to-side movement of the plane's nose, like when you shake your head no. The vertical stabilizer acts like a fin, preventing the plane from yawing uncontrollably. Just like a weather vane always points into the wind, the vertical stabilizer helps keep the plane's nose pointed into the oncoming airflow. This is crucial for maintaining a stable flight path and preventing the plane from slipping sideways through the air. Section 6. The rudder turning left and right. Attached to the back of the vertical stabilizer is another movable control surface called the rudder. This essential component plays a crucial role in the maneuverability of the aircraft, especially when it comes to directional control. The rudder is hinged to the vertical stabilizer, which is the fixed vertical surface at the tail of the plane. The rudder controls the plane's yaw, allowing the pilot to steer left and right. Yaw is the rotation of the plane around its vertical axis, which runs perpendicular to the wings and through the center of the aircraft. By manipulating the rudder, the pilot can change the direction the nose of the plane is pointing without altering its altitude or roll. When the pilot presses the left rudder pedal, the rudder deflects to the left. This action is similar to how a boat's rudder works, redirecting the flow of water to change direction. In an airplane, the rudder redirects the airflow. This deflects airflow, creating a sideways force that pushes the tail to the right and turns the plane to the left. The force generated by the deflected airflow is known as aerodynamic force, and it acts perpendicular to the surface of the rudder. Conversely, pressing the right rudder pedal deflects the rudder to the right, causing the plane to turn right. This is a mirror image of the left turn process, with the rudder redirecting airflow to create a force that pushes the tail to the left. The rudder works in conjunction with the ailerons, which are control surfaces on the wings, to coordinate smooth and controlled turns. Ailerons control the roll of the aircraft, which is the tilting of the wings from side to side. By using both the rudder and ailerons together, the pilot can execute precise and coordinated turns, ensuring the aircraft remains stable and on course. Section 7. Trim tabs, fine-tuning for a smooth flight. Flying an airplane requires constant adjustments to maintain a steady and level flight path. To make the pilot's job easier, airplanes have small adjustable tabs on the control surfaces called trim tabs. These tabs act like miniature control surfaces, helping to fine-tune the plane's trim. For example, if the plane has a tendency to pitch up slightly, the pilot can adjust the trim tab on the elevator to create a small downward force. This helps to counteract the plane's natural tendency and reduces the need for constant manual adjustments. Trim tabs are essential for reducing pilot fatigue and ensuring a comfortable flight. Section 8. Different tail designs, from T-tails to V-tails. While the classic empennage layout with a single vertical stabilizer and horizontal stabilizer is the most common, aircraft designers have experimented with various other configurations. One notable example is the T-tail, where the horizontal stabilizer is mounted at the top of the vertical stabilizer, forming a T shape. Another variation is the V-tail, which uses two angled surfaces that act as both rudders and elevators. These alternative designs offer advantages in certain situations, such as reduced drag or improved stability at high angles of attack. Section 9. Why the empennage matters. Stability in the air. The empennage might seem like a relatively simple part of an airplane, but its importance cannot be overstated. Without a well-designed and functioning empennage, controlled flight would be impossible. The empennage provides the stability and control necessary for safe takeoff, flight, and landing. From the vertical stabilizer keeping the plane from yawing to the horizontal stabilizer maintaining a steady pitch, every component of the empennage plays a crucial role. The next time you see an airplane soaring overhead, take a moment to appreciate the engineering marvel that is the empennage, the unsung hero of flight stability.